Hi, and welcome to Allen High School's discussion of acid and base chemistry at the APIB 1 level. Now, we're moving into a discussion of adding acids to bases.
Welcome back, kiddos. For phase 2 of our 4-beaker problem, we're going to mix things up a little bit. You notice I've rearranged my beakers. I now have my HCl, strong acid, with my weak base. And then I have my acetic acid, weak acid, with my strong base. So we're going to mix them up together, and then you're going to have to calculate, or with me, we're going to calculate the resulting pH. So here's my beaker. I have 20 mLs of my acid, and you notice I've got a little parafilm, so it's that kind of ruddy orange color. I've got parafilm on my ammonia because it does tend to smell pretty pungent. I'm going to pour in 50 mLs of that, and let's see what color resulted. We have still a fairly purple color. We're looking at it still being a little basic, but not quite what it was before. Certainly not nearly as acidic as my original HCl was. And we're going to calculate and see if we mixed what we were hoping to mix. Now in the second one, we've got calcium hydroxide and acetic acid, and we're going to mix that up. I have 50 mLs of my acetic acid. You see that pretty pinkish orange color there. And I have 25 mLs of my calcium hydroxide. And we're going to mix that up. Now, we got a new color this time. I have a golden orange color between these two. We'll check that out with our universal indicator, and we will calculate the resulting pH of adding a strong base to a weak acid.
Now, let's calculate what we would expect for these and see if it matches up to the colors that we saw with our universal indicator. Now, in this case, I have 20 mLs of HCl, and I'm going to add it. We added it to 50 mLs of ammonia. If your volumes aren't the same, please change your notes on that. Now, this time we do have to do a dilution because we added volume to volume. For HCl, I have 20 times 0.023, and my total volume is now 70, right? We put 20 into 50, so we now have 70. My new molarity of HCl is 6.57 times 10 to the minus 3 molar. I'm going to do the same thing for ammonia. This time I had 50 mLs of that 0.023 molar. And again, the same total of 70 times its new molarity. And when I calculated that, 1.64 times 10 to the minus 2. Now I have no other source of the ammonium ion or the chloride ion. Now remember, this is a stoichiometry. A stoichiometry is going to proceed to products until the limiting runs out. Since it's a 1-to-1 mole ratio, it should be very clear to you that this is our limiting reaction. 6.57 e to the minus 3. Just to be very clear, I'm going to multiply that by the mole ratio. I get plus 0.657 times 10 to the minus 3 times the mole ratio, and the same thing for the chloride. Mole ratio is 1-to-1. Okay, now I run out of my acid and I have excess ammonia. 9.86 times 10 to the minus 3, 6.57 times 10 to the minus 3, and 6.57 times 10 to the minus 3. Now, chloride has no acid-base properties at all. HCl is a strong acid and there's no base that could come. So it's just a spectator ion. I'm not going to worry about it. What we're going to find is that the results, the stopping point of our stoichiometry is going to be the initial in our rice. And as long as I have the original or parent acid or base, I'll start with that equilibrium. So as long as I have some ammonia, I'm going to start with ammonia acting as a base. So now we've done dilution, we've done stoichiometry. Now we have to hop into the equilibrium portion of this. And I noticed that I wrote this backwards on here. I don't know why, but we're going to just cross that off. That should be a 3, and that should be NH4 plus, and then this should be hydroxide. Okay, so I have NH3. Now, left over for my ammonia, I had 9.86 times 10 to the minus 3, not worried about the water. I had 6.57 times 10 to the minus 3 ammonia, and I had no hydroxide. Now this is a base, so it's minus B, or plus B, and 9.86 times 10 to the minus 3, 6.57 times 10 to the minus 3. This is minus B, this is plus B, and then B. We're going to neglect this. Now, what you notice is we have both a weak, in this case a weak base, and its conjugate. That's called a buffer solution. We're going to talk more about buffers later on, but I wanted to introduce that concept to you. Buffer solutions resist change in pH with the addition of a little bit of acid or a little bit of base. Now, you saw the KB earlier. I'm not going to set it up. It's exactly what we had in the earlier problem. And we have 9.86 times 10 to the minus 3. And remember, KB for this is 1.8 times 10 to the minus 5th. Now, this time when we solve for B, we get 2.7 times 10 to the minus 5th. My POH is equal to 4.57. I'm assuming you can move from here to here. Just take minus the log of your OH minus concentration. And then my pH is equal to 9.43. Remember, pH plus POH is 14. Now, what's interesting here is we have some product, and we're going to see that that addition of that product hinders the dissociation or acid or the base properties of the ammonia. And we know that because when we calculate the percent ionization, we get, here well again, we get the amount that ionized, B, which is 2.7 times 10 to the minus 5th, over the original 9.86 times 10 to the minus 3rd times 100. This time, I get a percent ionization 10 times less than what we had before, or 0.27%, far less. So the presence of product, remember Le Chatelier's principle, if you add product to this, you're going to shift a little bit, you're going to prevent or hinder that forward reaction there. Okay, we are going to do a similar calculation with our base and our acid. We're going to see, though, that we're going to push this neutralization a little further. In this example, we had a partial neutralization. I say partial neutralization because I still have some of my original base left. I neutralized some of it to get my ammonia. So it's a partial neutralization. And you noticed, hopefully, that a partial neutralization yields a buffer solution. So those are some key things to write down to reinforce what we'll learn later about buffers. So until then, this is signing off.